Hello everyone. So after understanding what is ecosystem, what is the classification, what are the structure and function, then what is food chain, then what is your food web, what is energy flow and all. Now we will discuss about what is the difference between habitat and niche. What is habitat? The entire geographical boundary in which movement of animal is confined, that is known as what your habitat. It is a large environment. It may be terrestrial habitat, terrestrial ecosystem or aquatic ecosystem, or whatever it may be. For example, you see a big place is there. This much is your terrestrial ecosystem and this is your water bodies. Understood? Now suppose what will happen, a tortoise will be allowed to move in an area. Okay. Now what will happen? First the tortoise will try to avoid the terrestrial ecosystem, then it will go to the aquatic ecosystem. Again in this aquatic ecosystem, a small place will be there which is more comfortable for this particular tortoise. So this particular area is known as what your niche, and this whole area is known as what your habitat. I hope this concept is clear. See the definition. Habitat, what is habitat? Entire geographical boundary in which movement of animal is confined. It is a large environment. What is niche? Small geographical area which is more comfortable for the organism, which is also known as micro habitat. Next you see we will discuss about your ecological pyramid. All of you know pyramid means that is a triangular shape structure. Okay. So the geographical representation of an ecological parameter in terms of your number, biomass or accumulated energy at different trophic levels in a food chain in an ecosystem is known as what your ecological pyramid. They are used to illustrate the feeding relationship between the organisms. The concept of ecological pyramid again given by your Charles Elton only. So this ecological pyramid is shown, represented in terms of number, how many numbers are there, biomass, what is the weight, mass, and what is the energy. Okay, on this they are classified. So if you see the first one, pyramid of number, you see, try to remember like this one you see, in case of grassland ecosystem, what will be the pyramid of number? You see, so many grasses are there, like lakhs of grasses are there, or thousands of grasses are there. On that what is happening? Some 100 number of rabbits are feeding. Now you see the number is decreasing. Yes or no? Number is decreasing. Okay. Now suppose 100 number of rabbits were there. On them what is happening? Some 10 number of wolves are feeding. On this 10 number of wolf what will happen? 2 to 3 lion will feed. Yes or no? So now what is happening? Time to time, the population number is decreasing. Yes or no? Population is decreasing. That's why it is always upright. You see, it is decreasing. The size is decreasing. Yes or no? Similarly, in case of aquatic ecosystem also, so many algae will be there. On this, few number of fish will feed. On this, bigger fish will feed. On that, a single shark will feed. This is also what your population is. You are decreasing. That's why this is also upright. Next, you see in forest ecosystem, so many trees will be there. On those so many trees, some few elephant will feed. On that few or deer or bird will be feeding. On birds, some snake will feed. On snake, lizard, wolf, some very few lion will feed. Yes, here also what is happening? The population is decreasing. Every case that is upright only. This is, I think, clear. Okay. But you see exceptional case is this one. In case of parasitic food chain. What is the meaning? On a single tree what happened? So many birds feeding. Here it was 1 and here it is becoming 10. Okay. On each one of these 10, what will happen? Some 20 number of insect may be feeding. So it will be how much? Your 200. So here what is happening? The population is increasing. That's why it is inverted in case of parasitic food chain. I hope this concept of pyramid of number is clear to you. Next you see biomass. To show the total biomass of individuals in each trophic level, pyramid biomass is better than pyramid of number in showing the relationship between organisms. Upright in case of grassland and forest, but inverted in case of pond ecosystem. Mass means what? Heaviest will be your tree. Herbivores will be lighter in nature. Lion will be even lighter in nature. Yes or no? So here what is happening? The mass is decreasing. That's why it is upright. But you see in aquatic ecosystem, very small lightweight plants will be there. On this some heavier fishes will feed. Okay. On this even heavier fishes will feed. On this heavier fishes will feed. So here what is happening? The mass is increasing. You see trophic level to trophic level, the size is increasing. That's why this is inverted. Clear? So pyramid of biomass is inverted in case of your your aquatic ecosystem. Next, pyramid of energy. To show the amount of energy transferred in each trophic level, it is always upright. We have discussed 10% rule, Lindemann rule. We already have discussed. Okay, it will always your decrease. That's why it is always upright. No need to repeat again. You can watch the last video. There it is mentioned. So this is one summary for you. Okay, summary for remember. Only remember these two, so that all other will be upright only. Pyramid of energy, always upright, always decreasing. Yes or no? Pyramid of number, grassland ecosystem, aquatic ecosystem, forest ecosystem, it is always upright only. But in case of parasitic, what happened? This is your inverted. Similarly, pyramid of biomass, it is inverted in case of aquatic ecosystem. All other cases, that is your upright only. Next, you see, next topic, last topic of this whole ecology syllabus, you can tell, that is a life table. Life tables are the tabular statements showing the number of insects dying over a period of time and accounting for their death. Okay, through time, how their population is decreasing. If decreasing, then what are the reason behind that? That is where your in a tabular formulation. That is known as what your life table. Okay, so a life table is a kind of bookkeeping system that consists or that ecologists often use to keep track of stage-specific mortality in the population they study. It is an especially useful approach in entomology where developmental stages, that means egg, larva, pupa, adult, those developmental stages are discrete, separated, and mortality rates may vary widely from one life stage to egg different, larva different, pupa different, adult different. From a pest management standpoint, it is very useful to know when and why a pest population suffers. If pest population is suffering, then it is good for agriculture. If pest population is not suffering, then it is bad for agriculture. Yes or no? This is usually the time when it is most vulnerable. What are the use of life table? Ages of different life stages can be known. Egg stage how many days, larva stage how many days, pupa stage how many days, and all. Key mortality factor, which natural factor are reducing the pest population, whether it is climatic like temperature, rainfall, humidity, light, or it is biotic like presence of predator or competition, or what is the condition. Population models can be given. Then pest surveillance, forecasting, prediction of pest can be possible. It is possible to regulate beneficial processes like parasitism, predation, inter and intraspecific competition. If they are there, that is what? Reducing your pest population. So definitely agricultural production will be more. So this is, you see, this is your life table. For example, you see in a hypothetical insect population, an average female will lay 200 number of eggs. So egg stage how many number of eggs laid? 200. Suppose what happened in this 200, predation happened. Some other predators came and they fed upon that. Suppose they fed upon 100 number of eggs. Okay. So how many left? 100 are left. Yes or no? So this 100 will hatch into larva. So what is the mortality percentage? Your 100 by 200 into 100. So it will be 50%. Now, out of 100 number of eggs hatched, that means 100 larvae came. They undergone some level of parasitization. Some other microorganisms or micro insect attack them. Okay. Parasitic insect attack them. You cannot tell micro insect. You can tell parasitic insect. Okay. Suppose what happened? Out of 100, 90 were affected by parasitization. 90 were parasitized. So how many left? Your 10 number of larvae will undergo pupal stage, 90% mortality happen in the larval stage. Okay, so out of this 10 what happened? 6 undergone abiotic stress, that is your freezing. They could not emerge into an adult. So how many adult will come? 4 will come. And what is the mortality percentage in pupal stage? 60% mortality will be there. Suppose the sex ratio is 1:1, so 2 female will be there and 2 male will be there. So such kind of tabular representation of mortality rate of this particular insect, any kind of insect, okay, with their region, what happened? In egg stage predation happen, in larval stage parasitization happen, in pupal stage freezing happen, what is the percentage mortality, everything we are showing in a tabular form. This is known as what? Your life table. Last point of this life table, in ecology the symbol R, capital R, is known as the replacement rate. It is a way to measure the change in reproductive capacity. Reproductive capacity means mother to daughter, from generation to generation. The value of R is simply the number of reproductive daughters that each female produces over her lifetime. Suppose you see 100 number of females, mothers were there. Suppose out of that 200 number of daughters came. That means what will happen? What is the value of R then? You see, count. Number of daughter is 200 and number of mother was 100. So the value will come 2. Yes or no? Next you see, if the value of R is greater than 1, here the number is 2. Yes or no? It is greater than 1. That means the population is increasing. It is a good sign. If this situation persists for any length of time, the population will grow beyond the environmental carrying capacity. They will try to reach their biotic potential. Okay, so this leads to uncontrolled population growth. It is a disturbed habitat, and introduced species or some other type of human intervention may be there. This is not good. Now suppose what happened? Mother were 200. Due to mortality, what happened? Not 100, even 50 came. Okay, otherwise 100 also, no problem. Okay, so here what is happening? Cancel 1 by 2. 1 by 2 means that is your 0.5. So 0.5 means it is less than 1. If the R value is coming less than 1, then the population is decreasing. If the situation persists for a longer period of time, the population will become extinct. But if suppose what happen, R equals to 1 only, 200 by 200, at the time the population is very stable, which is not that much possible. Okay, so here is a comment work for you. Those who are watching my YouTube channel and watching this video, they can take this screenshot and they can simply do this exercise, and they can write the answer in the comment box. Okay, so thank you for watching this 2 parts of this ecosystem video. This completes your whole ecology. We have started long back our ecology playlist today we are completing. I hope this was very helpful for you for different type of exams or for your understanding. Okay, so thank you for watching. Have a nice day.
अच्छा सुनो, सब्सक्राइब करते वक्त ना घंटी बजा देना, ताकि जब मैं ऑनलाइन आऊँ तो तुम्हारे फोन की भी घंटी बजे।